Hello, in this video we're going to talk about tangent planes. Now, before you get started with the computation of how to compute a tangent plane, I highly recommend you take a look at this video by Khan Academy. It provides a wonderful visualization of what a tangent plane looks like. And you can see in the video screenshot here, a good way to think about a tangent plane is like a post-it note stuck on a lumpy bumpy surface. Okay, so a tangent plane only kisses or just briefly touches that surface, just grazes it in the same way that a tangent line would graze or kiss or touch a curvy line back in Calc 1. So that's a great video to watch before you get going with the computations. Okay, so let's go back to Calculus 1 for a moment to remind ourselves how we found the equation of a tangent line. And then what we'll do is we'll crank that up a few notches to understand how do we find the equation of a tangent plane in Calculus 3. So most students, if you ask them how do you find the equation of a tangent line, they say, well, we're looking for the equation of a line like this red line that passes through the point x naught and then some y coordinate. Well, the y coordinate there is given by f of x naught. So we're looking for the equation of a line that passes through the point x naught comma f of x naught. And it needs to have a certain slope, right? So the slope of the tangent line from Calculus 1, m equals f prime of x naught. So let's put that all together. The equation of a tangent line, we can think about this as point slope form of a line. Okay, so how does that work? We say y minus y naught equals m times x minus x naught. And let's replace the pieces that we know. The derivative, f prime of x naught. Okay, let's keep that form in mind as we start to think about Calc 3 and what we're doing here. So in Calculus 3, instead of a curvy line, we're thinking about lumpy bumpy surfaces. So here's a lumpy bumpy surface, looks kind of like a mountaintop. Okay, and if we're interested in finding a tangent plane, maybe right to that point, a tangent plane is going to look like a post-it note or a sticker that's tangent to the curve just at that point. Okay, and so this is the tangent plane, and the equation for the tangent plane is pretty similar to the equation of their tangent line that we had up here in Calc 1. Equation of a tangent plane looks like z minus z naught equals the partial derivative of x evaluated at x naught y naught times x minus x naught plus the partial derivative with respect to y evaluated at x naught y naught times y minus y naught. Okay, so let's find the tangent plane to the elliptic paraboloid z equals 2x squared plus y squared at the point 1, 1, 3. So to be clear, this point is telling us what x naught, y naught, and z naught are. All right, so let's compute that. First of all, f of xy is the same as z, and we're given that that's 2x squared plus y squared. The partial derivative with respect to x is a function of xy, and that looks like 4x. The partial derivative with respect to y is 2y. And now we're interested in evaluating at the point x naught, y naught, or 1, 1 in this case. So that's just 4, and the partial derivative with respect to y evaluated at 1, 1 is just 2. So let's use our formula, z minus z naught equals the partial derivative with respect to x evaluated at x naught, y naught times x minus x naught plus the partial derivative with respect to y evaluated at x naught, y naught times y minus y naught. This means we've got z minus 3 equals 4 times x minus 1. Okay, so I'll just box in that 4. You can see where that came from. Plus the partial derivative with respect to y, evaluated at 1, 1. And that was a 2. So let's put that in. Times y minus y naught. And again, that 2 came from that partial derivative evaluated at a specific point. And if we clean this up, we can move all the terms over to one side, so we get 4x minus 4 plus a 2y minus 2, and that works out to be z equals 4x plus 2y minus 3.